Hello, in this video, we will see the simulation of 3 degree of freedom robot arm performing inverse kinematics operation. Okay, so here's the code of it. I'll be running the tabs one by one in Google Colab for simplicity, and it's lastly the simulation will be displayed below. So right now, I'll just start with the first step, which is all the libraries required for performing the inverse kinematics function. Then I'm defining the length of the links or the robot arm length as it is a 3 degree of freedom. So we have like 3 arm lengths. In that we have the final and effector position, the coordinates which the robot arm will or the final position of the robot arm to reach. And this is the phi, the total angle summation which we need to return. Like we need to return the say theta 1, theta 2 and theta 3 individually. Right now we are passing the hard-coded values, but we can also take the input from the user. Then we are just converting it to radian from degree for calculation purpose. Now here we have the inverse kinematics function. Uh, on the side by side, you will see a derivation of the formulas which are written down here. And here is its if condition that if cos theta square is greater than 1, then the robot arm cannot reach that particular point. So I'll run it. So we get the 3 theta values. As you can see, there can be negative values also. And in our robot, physical robot, we cannot pass negative values. So during conversion of Arduino code, we'll be using some operations like adding of 180 or modulo by 180 or making it absolute so that we can pass it into the robot arm for specific angles. But right now for simulation purposes, it will work. Now this is a simulation function for or plotting of the robot arm in 3D axis. I won't be explaining a whole of this code for plotting, like it's self-explanatory only. And now I'll just run it. So if I run it again, it will take some time. Okay, so we have this like a straight line in a 3D plane. It won't be clearly visible, like if we see it from different angle, it will look like different. But in 2D, we can clearly see it. So here, I also written the function to plot the robot arm in 2D. And as you can see, I've already just now ran it. And now I'll plot it again. Okay, so there was a bit error here, like the name L1 is not defined just because I've just defined it like small l instead of capital L. So I'll just correct it and rerun this code. Like here, I just mentioned small l, and if I rerun it, like we get this constant straight, like 90, 90, 90 degree.